Alright, so that one problem that we had from Chapter 2, Section 1, it asked us to put it in a standard form. So to do that, we first would need to factor out that negative of those first two pieces. So we'd have negative x squared plus 4x, and then on the outside the parentheses we'd have a plus 2. Now, I left a little room in here because we need to put an additional piece. So when you complete the square, you take half of that middle term, so half of that term would be 2, and then we square it. I would really like to see a plus 4 here, because if I did that, I could then make it a perfect square. But I just can't add a 4 to a problem because I've changed it. I can add 0 to a problem, so adding 0 to the problem would make them equivalent. So what I really have here, since there's a negative on the outside, I have really added a negative 4. But I need to add a plus 4 out here. And if I do that, that would give me a plus 6. So I have negative x plus 2 quantity squared plus 6. And if you remember from the Desmos graph, that's what the standard form was. Now let's look at something, let's complete the square in something different. So if I had x squared plus 6x minus 5. So new problem with completing the square. If I wanted to complete the square on this one, again, I'd keep this x squared plus 6x and have the minus 5 on the outside. So I'd take half of this middle term and then square it. So that would give me a plus 9. So if I add a 9, that means out here I'd have to subtract 9. No negative out here on this one. So I'd have x plus 3 squared. Again, this number that goes here is always half of that value, minus 14. So this equation is equivalent to this equation. This one is in quadratic. It's how they define a quadratic equation, ax squared plus bx plus c. This one is how they define a standard form of a quadratic equation. Alright, there also was how to find the zeros for this. So if you have, I'll back up to this one, negative x squared minus 4x plus 2, minus 4x plus 2, to find the zeros, I set it equal to 0. And I could try to do this by factoring. This one I couldn't factor to do that. So I could use the quadratic formula. The quadratic formula is x equals negative a, negative b, negative a, sorry, plus or minus the square root of b squared minus 4ac. It is b, sorry. X equals, there's a song that I sing to remember it. X equals negative b plus or minus square root of b squared minus 4ac all over 2a. So that way I don't have to look it up every time. I can just remember it. So it's this equation. For this quadratic, my a is negative 1, my b is negative 4, and my c is 2. So now I can just plug that in. So my negative b plus or minus the square root of b squared minus 4 times a times my c is 2 all over 2 times my a value, which is negative 1. So doing some simplifying on that, I get 4 plus or minus, if I look at that piece and take the square root of it, I have positive 16 there, and this is going to end up being plus 8, so which is 24. 16 plus 8 is 24, over negative 2, which I could divide each of these by 2, and that would give me negative 2 plus or minus. 24 is 4 times 6, so I could take out the 2. So 2 root 6 is the same thing as the square root of 24, and that's over negative 2. So I have negative 2 plus or minus the square root of 6. Since this gives me negative 1 and this is plus or minus, it'll still be plus or minus. So I have negative 2 plus root 6, and negative 2 minus root 6 would be my answers. Again, on Desmos you'd find a decimal, but here's the exact values for your zeros. And then lastly there was number 11, and it asked us to solve that algebraically. So let's do that one. 2x squared minus 7x minus 30. And again, if we are finding the zeros, we're setting the y value equal to 0. Now this one I believe we can factor. And so I'm going to do that method I did in chapter 1, the magic method. You could use the same quadratic formula if you wanted to, but I'm going to say, okay, I have a 2x here and a 2x here. I'm going to do the product of my a and my c term, and that's negative 60, and look for my factors of 60 that somehow I can get a negative 7. Again, I know it's going to be a positive number and a negative number. So I know there's 6 and 10, that's not going to do it. I got a 5 and 12, that might be it, right? Because if I have a negative 12 and a positive 5, that would, if I added those up, I would get negative 7. So I'm going to put plus 5 and minus 12. This one I can't factor anything out of. This one I can factor out a 2. So now, since I added an extra 2 in the beginning, in this first step, I will just get rid of one of those 2's. And so 2x plus 5 times x minus 6 equals 0. Set each one equal to 0, and you get x equals negative 5 halves. And this one you get x equals 6. And those would be our solutions to that equation.